Okay, well, welcome. Session 15. And we're going to talk about thin-walled pressure vessels. Might be helpful if I get the screen connected here on our end, but it's going ahead and it's recording. So, pressure vessels are found in a number of circumstances. And you might be storing a gas, you might be storing a fluid, you might be storing a liquid that's been pressurized that then becomes a gas when you expand it out. And under these situations, we are typically looking at systems with internal pressure. And when we say internal pressure, we're saying, okay, there's a pressure inside the vessel relative to its surrounding environment. So if you have a situation where the pressure inside the vessel is the same as the pressure outside the vessel, there's not going to be a differential, and you're not going to be so concerned about hoop stresses or circumferential stresses or longitudinal stresses, okay? And so as you go through the video, you'll see some description of the different types of vessels that we deal with, and we are looking at essentially two different shapes. One situation where they're spherical, like a ball, the other situation where they're cylindrical, so they're elongated. And in the case where it's spherical, the stresses in the wall, okay, are going to be the same. You can take an element on that wall that's spherical, and you can rotate it, and you're going to still have two components of stress, no matter which orientation, assuming you're orienting it on the surface. So what are we talking about? We're talking about these types of pressure vessels. Okay? And this is the equation that you want to keep in mind. And then if you're going through the video, you'll see this, that you have two sigmas, or a sigma in this direction and then a sigma 90 degrees relative to it, and they're going to have a value of PR over 2T. And then we go through the derivation here. Also, for the cylindrical pressure vessel, you have stresses in two directions. And it may be a little confusing. You're like, okay, which stress is the larger of them? Okay? And maybe one way to remember it is you can think hoop, there it is. All right? Because that's the hoop, the circumferential stress, or the hoop stress. That's the one you're going to be more concerned about. And it's twice, it's PR over T versus PR over 2T. Okay, so that's a basic introduction. There's a lot more to it. Go through the video, and I'll be here to answer questions. Hopefully it's somewhat interesting. The problems are a little bit tricky, okay? So we can talk about them as you get to them. There are 4 problems for this session, and they'll be due tomorrow, okay? Good. Thanks. Also, what I'd just like to mention is a little bit about exam 1. And for this, I am going to just temporarily shut off the sharing screen. Okay, so just so that so exam 1, the solutions are posted, and you should have gotten your grades. Yes. And then I posted this little chart as well. Okay, so this is kind of a histogram. If you're in this kind of first cluster, at least you're probably doing pretty well for the course. This first cluster from about, just under, around 16 and up.
I think I got the perfect.
Okay.
I know the perfect be higher. But...
Okay, so then over there, okay, and then here it'd be, that's probably looking at like B-ish range. Here, C-ish and or below, and then this is I'm concerned, but I'm also concerned. What I'm hoping to do is just sit down and chat with people for a few minutes about individual, and just go over how things are going with the homeworks and how things are going with after the exam. Okay. All right, so go ahead, work on the session, and I'm grateful that we have this time together. Happy Juneteenth to everyone. As we know, Rutgers kind of had the day off on Friday before Juneteenth, but today is the actual day. So happy Juneteenth. All right, so I'll go ahead and turn this back on. And yeah, we'll go. All right. Any questions on the technical content?
I have a question for one of the questions of this session.
Okay, yeah, sure. Do you want to ask everybody, or do you want me to just?
It's just like solve that, but I'm just like a little bit confused and like what's actually happening.
Okay, just give me 1 second. Okay, let me see where oh, here it is. Oh, okay, that's what I'm looking for. Okay, so yeah, so what are you looking at in terms of geometry? You're talking about the first one?
The fourth one.
Huh?
The fourth one.
Oh, the last one.
Yeah.
Okay. All right. You're moving along.
All right.
Okay.
That's some free time.
Okay, so free time. All right. Good. No, this is good. That's what you should be doing. Okay.
So it says the gauge pressure inside the cylinder is
Yes.
P, right? It's 17 atm.
Yes.
But like, so the gauge pressure, that's the one that we're considering in the stress equation, right? So this P is the gauge, right?
Okay. So if did you pull up that website, right? So the gauge pressure is the pressure between the inside and the outside. All right, outside, all the way outside. So in this case, what we're calling the gauge pressure, right? You see here, he calls there's a PC and a P, right? That he's naming, right? So in this case, if we look at the P, that's what we're considering to be the gauge pressure.
Okay.
All right, and then there's a PC, which is the pressure at the interface between the inner and the outer.
So that's like your reaction pressure because the one is like expanding or.
Right. So think about it. Yeah, exactly. So there's got to be a balance, all right, of essentially the forces between the inside and the outside. Okay. Well, I should say between. So it's an action-reaction pair essentially. So you have the inner composite cylinder, okay, and you have the outer composite cylinder, all right, and I think it's okay to pull up the website, right? There we go. Okay, so this is Professor Roylance's website where he goes over thin wall pressure vessels, and I think it's a great resource, okay, for anyone interested in getting some further background, which I highly suggest for this problem, okay, which is an example. So what they're saying is, yes, you have a hollow, hi Aaron, you have a hollow inside cylinder, and then you have an outer cylinder, right? And we're saying one's made of one material, one's made of another material. And then there's this interface between the two, right? Because you go from one material to another material. That is what they are calling, okay, a contact pressure or interface pressure between the two, okay? And so those pressures are going to be the same. All right, or like the one that's acting on the outer ring, right, is going to be the same as the one acting on the inner.
both
It's an
surfaces.
action-reaction pair. Sorry, I said that wrong, right? So it's at the interface. And what we can also do is we can think about the strain, okay, that is, or the displacement between those two, okay, and it has to be the same at that interface, okay. And so at that interface, what we're saying is that the elongation, okay, of the circumference, okay, is going to be the same for both of them. Okay, so for example, they use the term delta. If you go through here, okay, they are using. Well, I guess maybe here is not a bad place to put it. Okay, so you see, this is the strain. Epsilon theta would be the strain in the circumferential direction. Okay, and then if I multiply, okay, the strain by the circumference, by the 2 pi r, right, that'll give me how much change in circumference I have on this cylindrical pressure vessel. Okay, and those have to line up to be the same, right, at that interface.
At the interface. Okay.
At the
But
interface.
The outer is.
So the thing is, these are thin-walled pressure vessels, so we often assume that the radii are pretty close. Okay, when it comes to thinking about, okay, yes, because if you go out a little bit, yes, it's a little bit more, right? But the T, the thickness, the R outer minus the R inner is very small.
Like it's like 1/10.
Right, and that's one thing that we talk about in the notes, right? We're saying that, like you just mentioned, that the R, the radius divided by the thickness, we assume is going to be about greater than or equal to 10. Okay, good. Okay, so you're running along, you're chugging along. Okay, so what I'd like to do is just take a few minutes to sit down with each of you individually, all right, just to go over how things are going in the class, and we'll go to another room. We'll find another room to do that. So let me just find a room, and then I'll be calling you out, all right, in a nice way, right? Not calling you out in another way, okay? So keep working on things, and we'll go from there. Let's see, I think there's a room over here. Wait a minute, yeah.
doing individual interviews, kind of interview specific, but
Feedbacks?
yes. So it's, I'm not really sure what's happening.
Yeah, I took your room for you left.
Okay, and
It was so nice having that last time.
did you take the things at the door?
Oh, the door models?
Yeah, what about those also kind of soda, water,
We left,
in there?
we left early,
Haven't moved.
made his car. We left at 7
PM.
a.m.
Oh, really?
in the morning.
Saturday.
Oh, no, on Sunday.
Oh, okay. So you said the Saturday night?
Oh, well, okay, after you left,
Yeah.
I think Rishi took the room. Or not Rishi, Keith.
Okay.
I forget, to be honest.
Someone did. Okay.
All I know is I had that.
Someone did. That's good. Okay.
I was just falling down across the How do you feel about fire?
Fun actually. Somehow.
It was dangerous.
Why?
Just standing up, and the car back.
Yeah, the car right back. Yeah, car right to that long.
I mean, Daisy has an Audi, so it was pretty. As comfy as you'll get.
I'm sure it's better. I'm in a Rolls Royce, but
Oh, yeah. Definitely better than
okay. So. Mm-hmm.
Did you do session 14?
Something else. Let's see here.
Here. I would.
I did the first one I got last night. Second one I just met with Giselle.
I would want to do the first. So they were 4 like,
What's it called?
basically, I said that the shear average is false over area.
Yeah, basically F over A equals my over 2I. Is the half.
Oh, 2R.
Because shear force equals half of E.
Oh, okay, okay. Actually, I didn't know that.
Then put everything in, F's cancel out. And you basically have F over A equals FL H over BH cubed over 6.
What is MY? MY L times.
And Y
Yeah.
is FL times H. Y here is H.
So MY equals F.
H.
Really?
M is FL, right? First times left is moment. And Y here is height.
Oh, so it's like about the Y.
That's the one. And over 2I, y is BH cubed over 12. Times 2, it's 12 times 6. And you get algebra, you get H over 3, I think it was.
Okay, so.
Question 1 and 2.
Which one?
Yeah,
14, 14, 15.
Yeah, before I did those.
14?
Yeah, I did 3 and 4, but 1 and 2 I couldn't figure
Okay,
out.
I'm the opposite. I'm the opposite.
We'll trade dollars then.
Oh, okay.
Yeah. Well, sorry, I got 2, 3. I got 1, 2, 3, not 4.
Oh, and the halves cancel out.
Yes, that's true. Yeah, 2, 3 was pretty easy actually. It was just, and the formula is in the slides basically. Because tau equals VQ over IT, and then equals to V times BH squared over A, which they give, that's Q, over I, and you know I is no T is, because T is No, sorry, T is base. You're right, sure. For 14.3. Or Q3, rather. Pseudonym or something like that?
And then it's negative, right?
What?
That your answer
What's negative?
isn't your final answer.
First one,
For question.
No.
Oh, it's not?
what's negative?
Is in the formula.
Just- I didn't even know that. That's it. Apparently, I just wanted, Miss Wallaby.
Really?
Apparently, it wasn't there. I just found I skipped it. Like, maybe it would be, yeah.
2I over HA equals L.
What was I?
The one BHQ over 12.
Yeah, what was I? Comes out to be,
Aaron, sure. Well, we can do next, we can go next.
Okay, so. You got the F over A.
I'm thinking of one, so. I'll start with what I'm doing second. Like, so. In the package here, we just have over A. And that equals 1/2 half. And Y over. What do you want? I.
Okay, so that's,
And then my is just F times L times H. So your forces cancel out, and then you just rewrite.
MY is FLH.
Yeah, there's an air force.
That kind of makes sense.
The air force of is we want to know about Y, so it's like at the height.
Wow, I guess it's just moment times pi.
Yeah.
Oh, it's just weird.
That's weird.
Yeah, it's just weird because, I don't know like where we're taking elements. It's just length times force is more. So I guess if this is like, I don't know, 4.5. So I guess we take it like here. It's a magical force. And then, I don't know what height, I guess. And then I is, yeah, pH.
HQ. I just got that one. Wait, is this whole BHQ or just the H?
It's just H. Because, yeah. Never broke down.
What else?
Try to put B in some actually. That's so hard, but I spent like all weekend trying to figure shit out. Oh, yeah, so for rectangle, I is BH3 12, and circular is pi over 4, C4, and C is the radius, I guess. I don't think it's much, and then there's problems. Okay.
I need to learn to do it.
That sounds off. That sounds extremely off.
I was getting at, yeah, I was getting answers like, in the lesson.
I did. So FA over, FA equals FLH over 12. So it's 2.5 EH3.
Yeah.
And then you just cross multiply it, so you get F, so you get F, yeah, FLHA is equal to 224 times PH3 F.
You see like the last one? Where you at?
Yeah, this.
Yeah, so
L is equal to that, 24 PH squared.
what is it?
1/2 times 12.
No, but this is, wait, this is only. So this would be 2 over top.
Okay, so.
B6.
So it's 1/2 of 12.
I think it's been pretty good, yeah.
Yeah, I can think about that. I was like, yeah, if you don't, well, you get it wrong, there's like nothing I can do. Like, I just don't know how to get an answer.
Yeah.
Yeah, I told him that.
Yeah.
He wants more life improvement.
Yeah.
I'm not doing very well with
You
Sundays,
can ask
so-
there and he can help.
Yeah.
There was a lot.
So my problem is I do hours at 2 a.m.
Yeah.
So I can't ask.
That's enough, yeah.
I think I'll like it though. I think I'll like it. I'm at 2 a.m. trying to figure that out.
Same, just like this last, just figure it out. Which one?
So I think I've almost got it.
Which question?
We're doing one.
One?
Yeah. Oh, I guess.
So you can
Oh, so
just
the two
turn
was here.
everything in confusion. That's the age, right?
So I think I've almost got it. Let me just do this.
Opening numbers called, and a lot of percent. That's,
Yeah, yeah, yeah. So F over A is equal to F over E6.
yeah, just do that.
And that 6 goes here.
Right.
That's out.
Why is it over there?
Is that not how I?
No.
Goes up?
Up to there, yeah. Wait,
Was it that? No.
Hold on. It's now, the thing is, next time you have 1 over 2. So you do 2 times 2 over 2. Just cancel that out, it's supposed to be here.
Okay, so it just goes up?
Yeah. Basically, it's 6 over here. Okay. It's pretty straightforward. You have 1 over the other fraction. Let's say that, like that.
Well, I do 1/2. So it's equal to 1/4.
Well, and multiply the entire thing. Over to the rate, but get the point. 2 over 2. And this goes to that part, this goes to this part. 2 times a half goes to the 1. 2 times 1 goes 2. Right?
Okay, fair enough. Okay,
I mean,
so.
if you're doing 2 over 2 here, I'm going to say this way.
So we have 6. Right now.
So,
I'll just show you.
yeah.
So
F
we
over
have
3H.
EH3 F is equal to 6 FL.
Hold on. Let's see, here, here. There's the F here, the F in here, just put it there.
Hmm.
6 over H. So, that's insane. See, what are you doing here?
Well, I just did A times, 6 FLH
And you can do that if you want.
and BH3 times.
Sure. Cool. Means
That's
unnecessary to say you can do that. When is they here? They here cancel that for the day.
Well, regardless, we cancel that,
Yeah.
cancel that. And we just
change it to BH.
What?
Change A to BH.
Yeah, I'll just do that. Honestly, I just messaged that.
Did you read earlier? Everything's the same.
Let me see if I get it. This makes sense. I think for the second one, all you have to do is use double shear, which is F over 2A. It's just same problem. Right?
Yes, but I found that confusing.
How's that?
When I did that, it didn't work. He's only with this, but
Did you get the answer?
I did it. I'm pissed off. I mean, still answers, I know. Yeah.
What's the, do you know mark down for hours?
What do you mean? It's
0.75.
it's like too much.
It's like a lot, right? It's like
Quarter of a day.
That's way too much. Should be 10%. That'd be so much better. Actually, that's a question. Some better.
Procrastination is an issue, especially, yeah, whatever. What?
Yeah, I have the same.
This LDH.
Because you put this in when it's full. No, you plug this in, so.
So would you say this is the final equation?
What?
L over, or DH squared over 6 DH.
What?
Question one.
And then you
T
can cancel.
equals L. I guess you can cancel.
I have
Depends on the B and H.
I have that to H over 6 equals X.
Yes, well, there's two H over six. I'm just gonna do more. This answer is H over three.
There's a 2? What's a 2?
Hold on.
I just lost the 2. I have added 2. It's kind of all over the place.
I mean, I'll try it just to see what it works. Yeah, that's right. Yeah.
For six, over
H
six?
over 3, H over 3.
Yeah, over three.
I did.
What did we do? Hold up, so we have, what's two of that? No.
It's like single share.
No, because double shear is where you have over 2.
Yes.
I don't know why.
But, and always put the answer with three, so I don't remember, how I'm working with here. So, two of them, oh, right, so it was, yeah, no, wait, it's still over six, never mind. No, so,
You have 2F over DH, right?
yes, equals six F L H over B H Q, number one is six. Oh, right, two, sorry. Why is H over two? Yes, because, yeah, sorry, why, it's not Y, it's not M Y, it's M H over two,
MH
over two.
over 2.
Because it's half the height, is the point.
Yeah.
That's M.
M is FL,
Oh, so F.
this is incorrect, it's H over two. So you-
Well, yeah, but I already have this one half.
No, it's essentially, meaning, look. So, we have F over A equals F L H over two. Times one of two over B H.
Wait, why is H divided by 2? Is it because you measure it from the center line?
Yes,
Oh. So you measure the height, it's the center
Yeah.
line.
So the moment, okay, with this box,
yeah,
I was a little confused with this. Where are we taking the moment from?
what do you mean? So it's about that line.
got
I think so.
this
Well,
Android.
I'm gonna bring that in, right? Kind of. Well, the moment, well, here's that. And it doesn't matter. Let's just shear VA.
Okay. Well, because for a moment, you need the
Right.
force
Well,
times the length.
Ever's over there.
And I don't know where I'm taking the length.
So the I'm so the assumption is the force is there. At the-
Force is what?
at the end of it.
That.
If there's a-
Yeah, so force is
That's all.
like,
So basically, and you do that, that's the one.
yeah.
That's over there, right?
So is that?
That's not, but that's not, that's the way.
Yeah.
All of those,
Oh,
right?
okay.
Well, that's what. And this is, so why is it the Hence you have,
Okay.
hence you, hence F over BH equals, one second, let's be very
Well, I think I get the answer if I work it out, if I know that H is Y is H over 2. I just don't know how like we're supposed to assume that. I feel like my problem is
Well,
like
because the
too
point is
much.
y is not, is not something H. I was wrong before. Y is the difference, is distance from the axis.
Oh, so it's distance from like the neutral.
Yes.
Neutral. So
Which
then it's
is
like always that way.
Yes.
So every time I see my over
over I, yes,
y is the vertical distance
It's the
from
distance
the
from-
neutral axis.
yes, which may not be the entire distance.
Okay.
After all, if you're judging with point in the middle of the object, that's not just H over two, something else.
Okay, I think that makes perfect sense now. I just didn't know.
Yeah.
So
I just forgot what the false was. Yeah, so,
distance.
which one you have essentially, it's FL H over 4, put the whole on top, yeah, and then you 3 FLH.
Yeah, no, I
And then
think- I think that makes-
and then the 3 works out, and H over 3 will help.
that makes sense. Okay, I'll try question 2.
Isn't 2 students by 1 teacher 7 fathers?
Hmm? Wait,
2 students by 1 teacher 7 fathers.
why? You mean,
I'm managing your knowledge.
I don't know if I'd be able to do that. I don't think so. So it's on a double shear. When's the exams due?
okay, just keep doing, next week or so? Just next week? Next week.
And totally different deal. It's like doing conferences. It's just like talking about the exam.
And your current situation with what? He's due Wednesday, Wednesday, Thursday. He's gonna stand up tonight.
Which one was?
Whatever, whatever two of those days.
Oh, it's just gonna push it back a day?
Well, no, they do, that's Wednesday, Thursday, which was a few years ago.
The last one was a Thursday.
Oh, it's not really.
Okay.
So, yeah. So,
For so while. I should have been getting like 4 hours of sleep every night.
From last week, I didn't get sleep. So it's fun.
Well, I was just cranking down Red Bull after Red Bull. Every morning I would get coffee from some breakfast, and then some of the people there were eating off free Red Bull, so I was feeding me for you.
I just took 2 cans of Coke today. That's all I got. When they did design out there.
The bracelet will score the highest for design.
Yeah, another 1 point, so, yeah.
And then the bracelet of leaking during that.
Yeah.
You didn't see
Which one?
the last one right
I
past.
wasn't there.
Oh, you went there.
I'm actually,
Oh, so we passed that.
I didn't leave.
They didn't know. Because Alice,
Yeah.
Alice was just like,
So I was,
he sees it, and I'm like,
I pulled a pig.
I'm just like, shit. Goes, gets around, goes back. He said the puddle was 2 times bigger than the puddle was when he left. Right?
So you did.
But who quits the thing, it's just like this is his friend with the judges at the back, and he's just like this, right? And every time the judge came over, he would just stand like that on top of the racks. Like you literally just see the trail, like the footprints of brake fluid from his shoes, just like all around the car. And then like the judge like somehow didn't notice. It was Kevin.
So, okay, well, maybe notice it's maybe not probably.
But Kevin goes, he's like, congratulations, you guys passed that, and he slaps the sticker on our car. We're like, okay guys, and we just reel the car under so fast, and you see the trail of blood brake fluid rolling the car out.
Is car actually going next week?
I hope so.
It's actually good.
That's why I did the first. I mean, mechanically, it's just to keep electronics guys out of the accumulator.
Yeah, again, that thing is that
Is it an accumulator part?
I can't remember what message is on. What actually happened?
Yeah.
Who's?
Florida's was the ones right behind us.
What happened?
So they left their accumulator in the trunk.
How?
Of their car.
When?
Because they were getting ready to go home. So they put the accumulator in the trunk, drove the trunk. I guess
That's
the
very
trunk
clever.
got caught. The car on fire.
Covered then?
Oh, but yeah, we see the video pretty well.
What do you do?
That was a car. Someone's battery pack for it.
Is that a fucking test?
No,
No,
it's.
their race car battery wasn't in the truck. Wow. It's the fire department doing anything?
Yeah.
Like track by the number or the?
I don't know, it's something.
You missed it.
Yeah. That's so great. Well, you can see Eric in the videos. Actually. Look at Eric. There you go, the fire extinguisher.
That's so stupid. I really like that. passed back with Portland?
They did, and they passed back, they passed it from very fast, they failed very fast. They
Okay.
failed very fast 3 times.
Hold on.
Their accumulator is filled with water and they failed very fast.
There's some dreams in there.
They opened their drain plug and poured it pouring out.
Dream plug, what's the dream plug? I'll plug it. First place. It's open, no pass. That's stupid. Do that.
It's scary. What the fuck is he talking about?
What?
I need to drop this class.
Yeah. I can't have you like reproduce it.
Says you figured it out.
Hmm?
For 2?
You figure it out.
Yeah, it's not 1/6.
It's not.
H.
It's.
That's what you got, right?
I thought I also, and
That's
for
fine.
some reason, something else. Some reason it's screwed with it.
It's 3 I'll just go.
Crazy with it. I don't know why. It needs to fit it. Hold on a second. No, so, sorry, no. 2H over 3. Yes.
2H.
I don't understand this one. I don't understand.
George, for the first one, it's just H over 3. Oh, we extended this one.
Which one?
That is kind of
Which one?
the one that we just did.
I don't think so.
14.
Yeah, did I just kind of one?
No, you gotta go back.
Yeah, the grade is, I was looking for it.
Oh, okay. You're off the.
Just was like, I got 10.25. So,
What,
a little worse, I guess.
exam?
And he was like, how do you study?
Yeah.
You seem to like, I just forgot my units like 12 times. His was like, he was like, yeah, your understanding seems to be better than what you got, but like, that units. But yeah. And he was like, yeah, I'm not so worried, as long as you get your homework grade up. And I was like, yeah, but like, if I get homework wrong, I don't know what to do. He was like, yeah, about that.
But yeah, that's what you like.
Yeah, it's like, you.
This a you problem.
I heard RBS is like,
Okay, how about, hey George. Give you next map.
Sure.
Alright.
He wants to go to George. He was rich and sick. That's not gonna work. He was like, I can't say you. I'm also. If you want, I can show you how I did it.
Cause
See, like,
I'm getting
I
to
just did it now. I got one. We both got 1/6 each. Strong.
Yeah, that's exactly what it is.
So,
Perhaps
so add
2/3.
2,
2/3 of perhaps. What was it?
2/32.
Yeah.
So add 2A, it's double is FL, Y is H over two, because it's from like the neutral axis, right? All over I, H should be over 5. Is that kind of what, sort of?
Yeah.
So then we get my algebra.
It seems like, from algebra, it should be over sector. Right?
Yeah. About these homeworks is like, I'll look at that problem, I just don't know what the fuck's here. But like the second time, it makes perfect sense. But like, the problem is homeworks, it's only one time. So.
I mean, I'm traveling time to go into, it's just.
Yeah, I did three.
It's just basically follow formula. It's just simply B cubed over IT. T is B, B is F over A, which is B. B is given actually. B is given the balance is those. And then you have I is that, and then B is T, and then just plug everything in, that works.
Okay, so B is T.
That's B. No, T is B then. Because, yeah.
B Q equals I over T.
And plug everything in. B is given, Q is given, I you know, and T is B. Then plug everything in. 4 on the hand is like confirmation. Yeah, there's more.
It's just always how it is.
And maybe there's we'll pay a 75. Well, pay a 75. Yeah, I mean, basically everything, I'm good by that. So, yeah, really catch up. Get ahead of it.
Yeah, so I got this, okay, so for this algebra, I got the same as X.
Aaron, is H migrate to the neutral axis, or is H what they give you?
For what? That problem?
Yeah.
Use what they give you.
So,
for all
so
of
what
them?
it's like,
Yeah, just follow this example. BQ over IT, it's just that.
so when it's like MY, it's like M sub Y. or
And
something.
why is that template? Where?
Well, I don't know what
What?
it is,
For
but
what?
when,
Why,
when,
whenever I?
when you see like
Y is moment around.
M sub Y, right? Or on right hand Y.
whichever
The
the sigma equation is,
and whatever I?
is that a sub or?
No, it's not.
That's just
Study.
Alright, so just rule of thumb.
What?
What's the
Rule of thumb, when you see M, Y together,
28, so.
that's from the axis.
Yeah.
Y means distance from joint.
Almost always.
It's
Unless it's
not-
given, then
and
it's
it's-
just.
and it's
a
equation-
rule.
and it's equation has it for me.
If you start studying.
I mean,
Makes sense.
different equations means different things. And hopefully it's consistent with that's not necessarily the case.
Yeah, no, I agree. I gotta see what my calculus.
It's class 11. And there's a reason why, I appreciate
Yeah,
it.
but,
Yeah.
yeah, I'm not sure if we're living mine every day, just because I
Yeah.
have, calculus.
There is things there, engineering and job. Oh,
Yeah.
it's just, as long as you know the basics, you're good at that. Because you can share with them everything else. And then they use themselves out.
True.
So,
True.
Hmm? I don't know yet.
I think there's only so much I can tell you.
What does that mean?
Well, wait, wait,
It's fully,
Almost ended?
so you get it right, I did get it right, so,
The problem is that
I'm just,
this is a structure, right? For the people that know what they're doing, they actually do it well.
it's pretty simple how I got that answer. The problem is, this is like a little more sober.
You just.
But it gives me confidence that we can actually,
Do you?
you know.
You did the test?
It's like the only problem
Because if we're gonna be
ever
doing
had.
This is so annoying. It should be, pictures numbers, or the what?
But this was,
By the time you come back to this, after
It's
that,
like,
you're
yeah.
gonna come back
it's like the only problem, it's just not useful for me, yes,
to like,
but.
that's also.
I was desperate at 2 hours trying to get a
That's
couple
also
more
why you
points.
probably start studying
So
more
it's
for this,
Q
so that way
X
we can
times
really
R
get this
is
down.
10 times
So
into the
we don't even really.
times the
study
centimeter
for
conversion
Just focus on the
times
first
that
step.
conversion over 2. Which you get really close to that.
I have to go to class, but if you guys wanna go, I can meet you on campus.
Their numbers were,
Yeah, cause if
9,
you guys
4,
are
6.
Not today.
So just replace them.
in the future, we still over.
I don't know.
We're gonna start focusing on it.
Some of this numbers on check, they do like different rotations, which is kind of helpful. So make these wrong with these
We'll
guys.
start like Thursday or something.
Maybe Wednesday. Maybe we'll do like a call Wednesday.
Yeah.
That was cute. Cute. Jack is not.
So I think we're happy with that.
Jack is not crazy.
So,
What question are you doing? He's doing 14 full. If you do that, right?
it's your,
For 3, he did the operators, right? I do 1, 2, 4.
Yeah, thank you. You want me to just leave that for?
Yeah.
You can your computer back.
Their numbers.
wait,
So I want your text.
Thank you.
You need 4?
Or
I'll do 4. Very good. It says 3. Where do you go last? So far.
wait.
No, so it's the. Shop Zoom.
I can make it.
I'm not news there.
What's the conversion for APN to PN? It's like 101.
1.55 pascals in one APN. It's not bad. It's 5 years as well. And minus 10 cents version. That's what I just did. But benefits from the ATM, it's right there. I mean, I didn't look at it either. I mean, a few years as I have this, but I hold this, I have many instances. What was the ATM? It goes in case of that stuff. I got it for you. It's 101.325 KPA. There's 101.325 pascal. 0.11325 megapascal. So yeah, that's that. You get the gist. No. No.
So what was you guys getting caught?
Pretty much.
Got ass.
Beat MIT, so there's that.
MIT?
Yeah, I might be that.
There are. They're just like,
Teams actually
they
raised
sign, pussy. There will be a, Saturday.
Bro, why do you have to go cheap? Yeah, I kind of. You feel so different. You feel so different. You saw the Rich said George happy to too.
What?
George said George happy to too. That's why I don't have to see the Rich like.
I just called them actually.
Right?
Yeah.
It is probably like 9 in the morning.
Why are you still fucking talking? Shut up. Yo, but it's hot as fuck over here.
Because we're 70 degrees in the
Nah, I could. I would.
Did you plan to the internship things yet?
I know I had it.
You're going to?
I'm gonna do it today.
Just generate the open test.
Yeah, apply for what?
At the event, there's like little companies there trying to get you internship. I try to get your Let's do it for you. Putting in a list.
It's a, they're definitely making out right now.
Well, that's all.
He said all that. It's just because I didn't have it, so now she's gone. There's two.
You're the last one, right? Everyone else?
Yeah.
We got two? Okay.
it's 30, isn't it?
It's 25, but I'm assuming after his last thing is done.
You can do whatever you want, really.
That's exactly it. But I got your this.
Is this like, you know, is this equation just like an equation?
So,
For
criminal
max,
offense.
What do you do the homework study already?
Yeah.
Okay. So it's just like this.
It's only the same. What's the question? Is,
Like, is this just an equation?
what else was it?
Tau max equals 3x.
It
It just seems weird.
So
That's
what?
what it is.
What?
Or not.
Volume of the sphere is,
It says tau.
4.3 pi r
I'm
cubed.
just wondering, it just seems like a weird equation to have.
So this,
Well,
look,
it's-
I think I thought it was conversion split, right? I don't know if it's actually standard meters or like centimeters or what, right?
They'll be,
I don't know,
each should be.
estimeters, basically.
Yeah.
So when the one stuff,
How many
it
meters
can work it out.
for this volume? Okay, 4.3 pi r.
Because sigma max, sigma max, wing max, we're all
I'll do it again.
Three,
So,
Oh, this is.
You don't know, yeah, I get you.
Each
So I just got it wrong.
Please.
This is the equation we
Yeah.
get, the stress equals pressure.
In
We just
the
solve for,
negative flow.
I turned that
Well, sorry, what we call, which is 12 spirit there.
R.
Also, do you understand how to make these graphs?
Thickness right down.
I was gonna ask him, but
We don't have thickness, so
But
I
then,
can thickness
because like I
is
said,
R over.
yeah, it's not us.
I mean, so Jeff makes it.
Yeah, we're trying to find
video.
Yeah, it's fine, right?
Okay, wait, let me try to do another.
Jeff Hansen.
So is it,
So this video is.
should I look
Yeah,
up?
right, so I'm not found.
What is the-
They like, when I'm trying to study for the exam, every single video, they talk about different subjects. But
Yeah,
we're not learning that.
Yeah, that's why you should use the actual course to study the exam. Because otherwise you can just, or we're going to waste time doing things that don't help you.
Okay. A liter is
Nice.
1,000 cubic centimeters.
What?
Oh my fucking god.
What is it?
I think it's 1,000 cubic centimeters.
What is?
A liter.
Yes.
Should have said this guy, he definitely knows.
Of course.
So wait.
Do you think he's gonna post the answers for the exam?
He did.
He did?
It's in it.
It means like, which is something I didn't want to do. I wanted to procrastinate, but like not be my fault, so that it wouldn't see stress. So 6,000 cubic centimeters,
Wait, that's your.
93,
Oh shit. I mean, it's.
82. There's some of that haven't. Like, for example, the one with 9 total points, there's
What was
3
that?
questions, unit 8 or whatever, we had to use like those code, like the 3D design, like the CAD.
Was it 9 points?
It was 3 each. It was 1 point for your answer, for
I
like
think it was going also.
the typed out answers, and then 2 points for picture of the
Yeah,
pre-pro max.
the annoying thing was I did the simulation, but the half of it goes to it.
Well, I just couldn't download on my computer.
In Mac?
Yeah, Max. I couldn't.
Well,
do
yeah,
the
if
program.
you.
By the time I found out, I I was working all weekend, I wouldn't have time to go to drive an hour
Yeah,
here.
I would lose my
You're
computer, a computer as a boot camp. I just went there and did it on my computer. Yeah, but I had boot camp for SolidWorks and such, so I just did it on there.
I also have a PC at home.
Hmm?
I have a PC
So
at
there you
home.
go. Let's go.
Oh, so okay, that's where I messed up. The Saturday.
Okay, I
I do the
got-
same exact process.
So I got, this is my, this is what I got. So
Yeah,
what's the
yeah,
much?
so it's
Okay, hold on, I'm just taking attendance before.
Yeah. So you divide 4 by 3 and 5.
So
Listen, do we have the answers stated?
They're on the website. If you go on the front page where all the previous practice problems were, all the previous practice exams are, they're there now.
Here's an ATM, right?
So then I got 26.83.
Yes.
Okay. Technical questions. So which one?
14,
Say that.
session 14, question 2.
Session 14, question 2.
I can show you. I can show you like where both of us are going wrong.
Yeah.
Where what?
Basically, algebra or not the issue studies. The answer is 3 issue. I don't know why.
Okay.
So both of us are getting 1/6 H.
Yes.
Get by this, but apparently the answer is 2/3 H.
Right.
And we just have no clue. So this is the algebra we did.
Okay.
So if you want to look and maybe
Yeah.
if there's
So yes. So this is my algebra, which is also messy. All right. So we have to get we're seeing that
So you're getting some.
the average shear stress needs to be half the maximum bending stress.
and it's for double
Like, P over 4.
double shear.
Multiplied by 3 divided
All right.
we
So P over 2VH.
Mhm.
All right.
F over 2A, same thing.
Right. That's good.
Okay.
Divided by 4.
All right.
1/2.
Is equal to
PLH.
1/2.
You have H. Oh, I guess that 2 is the H over 2, right?
Okay, so I got
No,
20.
This is 1/2, right? And then there's yes. Then this is the 1/2 times the whole thing, and then 3PLH over 2
That's in the
EH
Why is
cubed.
it just 2? Why is it 2?
3
Why isn't it B? Isn't that BH cubed as well?
It's H over 2.
Right. Where's that 4 coming? Where's that 4 coming from? P over 4.
PL over 4?
Yes.
Oh, that's coming from here. That's the maximum bending moment.
Oh, we just got it.
Well, because it's the, yeah, it's got these meters.
Wait, sorry, can I say something?
So,
Yeah, 'cause it's a-
I was just thinking
Mhm.
PLH,
but still in meters, so.
H over 2 you have, and then you just have 4. Okay.
Yeah, and then
I
there's
guess
a
I just
1/2
need
times
to-
the whole thing.
You take those notes, I guess.
Yeah. So the PL over 4. So I don't know which one it is. Where the issue is there.
Oh,
But
the
yeah.
over 4 mistake.
Yeah, we
missed over
just
4
don't,
part.
we have this,
Yeah.
which is everything but
So
the.
we just
Over
keep
4.
that in ATM.
Yeah.
I
So
guess.
yeah. So because we got to figure out what
I
the
guess
bending
that would be
moment.
4, actually.
This is because it is tricky, right, to think about. So this is a 3-point bending problem. Okay. And so, you can do it a couple of different ways. You can do a method of integration, right? So for example, if I take a slice here and I cover up the right, then I know that I have a constant, I have I have a constant shear force of P over 2 to counteract that one, right? And I know that it's a pin, so I have 0 moment there. Okay, and I can integrate the shear force to get the bending moment,
Okay.
right?
Yeah, actually, my next question was to ask about how you make those graphs.
Right, so that
So,
was,
I
yeah,
guess
go ahead.
you draw it out, this is double shear, so it looks like that,
Mm-hmm,
has two forces.
mm-hmm. Yeah, so this is be a beam bending problem.
Yeah.
So this right here is the beam. That bolt is the beam, and then these are the two forces. Okay,
Yeah.
here,
That makes sense.
okay.
So then for your shear force, yeah, I guess it's just, I guess I should just know that.
It's not just
It
a,
just like goes and drops off.
no. So I mean, yes, I have to do it every time.
Mhm.
Okay. Let's just do it out, right? So look, I'm going to do first things first, right? You do two-step, external equilibrium, right? So actually, maybe I'll just do this on. Let me just do it here for everybody,
Yeah.
okay? Because it's enough so that we got it. Okay, there's enough
Like
here.
pressure?
Yeah.
247, 165,
Okay, so there's a question about. I guess this is under 14, really. Okay.
I got 2-4.
Yeah.
Wait. Why did you do this?
So there's a question about double shear.
Why did you do this?
I got 1.0135.
So yeah, it's 10 times
0.101.
so this times.
Oh, no, that's. No, I got more. Oh, I got it.
I got 12.
1.01.
Okay. So there's a question about double shear, and this question fundamentally is, okay, here's the beam. This is a beam right here to here, in here, okay? And we can model this, the way we're modeling it, as saying, let's have a couple of forces like this, okay? Or this is maybe better pointed out. We're saying that it's a 3-point bending problem. Okay. So we use symmetry. So if we do external equilibrium, this is kind of that external equilibrium, right? We say, okay, since we're assuming that this length L/2 is the same on either side of them, then we can say, well, these guys have to be the same. All right, and we can do that by bending moment actually as well, right? If we look at okay, taking the moments about here, then this P times L/2 has to be equal to P/2 times L, right? Just, I mean, if we want to look at external moment, right? It's like a lever problem essentially, right? Then we just have 0 is equal to minus P times L/2 plus P/2 times L, or whatever that would be, the R, right? And that has to equal 0. Okay, so that works out. Now, how do we go about figuring out what the internal shear force is? Well, we can just use the cover-up method. We draw the beam, and we use the convention. Okay, the convention is that V is down when we expose the right, and M is like that. Those are the internals, right? So in this case, and we would say that we're moving across, you know, with some X. For all values, okay, that shear force V is just equal to P/2. Okay. Now, what about the internal moment? Well, there are a couple ways to, at least until you get to the middle. Well, the internal moment, that's maybe an interestingly tricky one. Maybe not. Okay. What do we have here? If we take the moments, let's just say we say moments interface. Okay. That'd be here. Okay. The V makes no contribution. Okay. This V makes no contribution because it's in line with the point of interest, right? We can say we have a positive M. Okay, but then we have something interesting happening over here. This M, all right, so what is the distance? There's a moment being applied. We're taking it about here. This M is counteracting this P over 2 times X, which is acting in the negative, right? And again, that's equal to 0. Okay. So what does this mean? That means that M is equal to P over 2 times X. All right. Which, so if I'm drawing the bending moment and the shear force diagrams, right, all I've got okay, at least up to this point, the L over 2, okay, I've got a constant P over 2, right? That's what we calculated here. And we have an expression P over 2 times X. So this goes up with some slope, okay? That slope is P over 2, which means that when I get to L over 2, P over 2 times L over 2 is going to be PL over 4. Just like that. Okay? And that's that value. This problem is symmetric, so there are a couple things. You could draw it again, or you could say, wait, this problem is symmetric. So whatever is happening, it's increasing, okay, over here. So it'll be increasing over here. So going that same direction. So that you could use for the moment. Something peculiar, though, happens with the moments, or with the shear forces. Remember we talked about what happens when you apply a concentrated shear force? Okay. So if we apply concentrated shear force, it actually drops us down by a value of P, and we get down to negative P over 2. All right? If we're using like the rules using integral methods, all right, we say, oh, there's a concentrated P, so it just drops us down. Another way, though, to look at this is, say you don't want to use any of those integral methods that we've talked about, right? The other way is to say, well, I'm going to expose the right side. I'm going to expose the left side, okay? So when I do that, I use my convention that V is upward and that this is M, okay? And we have a P over 2 being applied on that side. And this is where it gets a little bit tricky. I'm probably going to say I have a new X, we'll call it X2, coming that direction. Okay, so now the X, it's coming this direction, it's going this direction. So from this right side at X equals L, it's going to the left. Okay. I could define it from this direction as well if I want. Okay. Let's just call it this way though, for now. All right, so V, what does V got to be equal to? Well, once again, we do equilibrium. So when we do that, what do we see? We see that P over 2 plus V is equal to 0. That means that V has to be equal minus P over 2. All right, so this is correct. All right, going from the right side inward, it's minus P over 2. And this delta P is the P, or minus P. Right? So either way, we could either doing it straight from equilibrium like you did previously in statics, and we did in this course, we get this result. Now, what do we do? And what I'm trying to say here is the other thing that we've talked about recently is that the delta V at x equals L over 2. Sorry. Is equal to minus P. That's this P up here. Like that. Okay. So that lines up. We're showing you could do it two ways. One, you just know that this is a flat line, and then boom, it drops, and it's still a flat line. Okay. Or you do this with equilibrium. Okay. Either way. Now, what about M? Well, let's do the sum of the moments. And let's go ahead and we'll do them about here. Why are we doing them there? So that we don't have to use a V as well. So in this case, okay, we have what looks like a minus M, okay, plus P over 2 times X2. So what do we get? Once again, we get M is equal to P over 2 times X2, right? And this is being defined where this is 0. So that means, once again, when X2 is equal to 0, or that means that the big X is equal to L, what do we get? We get M is equal to 0. So this comes out here, all right? And if we go to X2 is equal to L over 2, at the middle, that's the distance we're going from right to left. Once again, we get PL over 4. And so it meets up like that. Okay. So there are multiple ways to do this. The other way to do it is to say, oh, look, this is a flat line, and I'm going to use my dm dx is equal to v. So you could say that m is equal to the integral of v dx. All right, that's the other way to do it, remember? And so if this is a flat line, when you integrate, it comes out to be a sloped line. Okay. And it's doing that from both directions. So that's how you figure out what this is for. This in particular was for was it session 14, right?
I think it was 2.
Question 2, right? Because we got to figure out max moment, right? Because we're trying to figure out what the maximum bending stress is. Okay, so that comes from this point right here. And then the sigma max, all right, we know that is, we know that we have it at negative my over I. Okay, so we have our PL over 4, we have our h over 2 because we're halfway up, and we have our I, which is BH cubed over 12. And what we're saying there is that we're trying to make we're using half, right? Because it's saying that what I put in there was that it's half of this is equal to the shear force from double bending or double shear, right? So so we're going to have another half term that we introduce. We're saying that the shear from double shear is equal to 1/2 sigma max. Okay, and then solve. All right, did that help clarify a little bit? Oh, we went over. All right, thank you guys. Thank you for sticking around. Okay, if you have questions, please feel free to send them in the GroupMe. If they're grade-related questions, please use Canvas. All right, and I'll see you next time.